Welcome to Easy Math TV. We're going to start a series on statistics, and this is going to be a playlist that is focused on how you can simulate or create your own data sets, and based on existing types of data distributions that you're going to be studying and that we're going to be working with. So um, it's important that you review what a data distribution actually is. Um, a data distribution really is just talking about it lists all of your outcomes and basically talks about likelihoods of those outcomes occurring. That's what the distribution is all about. How your outcomes are distributed. Um, do they all happen at about the same frequency, or do they have different likelihoods associated with them? So there are known patterns to outcomes in data. Those known patterns are called distributions, okay? So let's backtrack. Let's just start with just reminding ourselves that data is really just information. It can be numeric, it can be descriptive. Um, in nature, it's just information that we have written down or that we have observed about something. So the data we're going to be dealing with today is both discrete and quantitative. So just to remind everybody, discrete data is where the outcomes are finite. So there's a finite list of outcomes, and it's a reasonable list, reasonably lengthed list of outcomes. So like if you had 1,000 different outcomes, then we might not consider that to be discrete anymore, because there's just too many outcomes. But if it's finite and it can be listed in a reasonably manageable way, then we call that discrete. It's quantitative in the sense that our outcomes are numbers that can be listed from smallest to largest, okay? So it's both discrete and quantitative. And the type of distribution we're going to be learning about or creating data for is something called the discrete uniform distribution. So the discrete uniform distribution is something in statistics that has to do with outcomes that are all equally likely. Um, so we're going to call capital X a random variable. Capital X is a random variable that represents an event. It's an event that occurs that we are able to assign an outcome to, okay? So we call it random because it's a random event, and we call it a variable because there are multiple different outcomes that could occur. So it's not just one possible outcome. There are lots of different things that can occur. That's why we call it a variable. So, and then we use this squiggly line to represent um, what it what we want capital X to represent. Like what does it actually come from? So what kind of population or what kind of pattern does it come from? So the squiggly line just means that X is approximately uniform. So UNIF is uniform. And then we use curly braces. The curly braces are basically just identifying that it is a discrete uniform, because there is a continuous uniform distribution as well. So we want to distinguish between the discrete one and the continuous one. So we use these curly braces when we want it to be discrete. Okay? Curly braces. And inside those curly braces, we have our range of values. So think of that as a range. And if it's just 0, comma 1, then the range of values is just, there's just two outcomes only, 0 and 1. There are so many different things that can represent that, like on versus off, or yes versus no, or heads versus tails. Lots of different things that we can think of that we're measuring that have two outcomes to them. And we're going to be getting into more of that later in a couple weeks. Another possibility could be a random variable capital X is approximately uniform on a range of values from 1 to 10. So maybe it's a 10-sided die, or maybe it's a survey where people had to rank something on a scale of 1 to 10. So maybe you were just ranking something on a scale of 1 to 10. So one is a possible answer, 10 is a possible answer, and anything in between are also possible answers. So those are examples of discrete uniform distributions. And in order to create some data, we're going to need to visit a website called rdrr.io /snippets, and then another /. So rdrr.io /snippets, and then another /. And when you go to that website, you will see an entry, like there's a window in front of you that you can enter stuff into, and there's already stuff in there that's been preloaded, but we can delete all that and we're going to put our own things in. So one of the first things that we need to know is there's 5 lines that we're going to type in. The first thing that we're going to type in is what you see right here. I'm going to put a box around it. That's the first thing that we're going to type. And what that means is that we need to be able to use a special package. The package allows us to have access to the discrete uniform distribution. So we have to type require and then parentheses extra capital D ISTR close parentheses. And just keep in mind that anything that we type in here is going to be case sensitive. So if you see a capital D, it's got to be a capital D. If you see lowercase letters, they need to be lowercase letters. Okay? So that's the first thing that we're going to type in. The second thing we're going to type in is our actual data set, or actual data that we're going to be creating. We have to give it a name. So this entire thing that you see here is giving our data a name, and it is also storing, it's going to store the numbers that get generated into that object that we're calling D20 roles. And we're creating it out of the uniform distribution. So you'll notice it says D20 roles equals RDUNIF. So that means discrete uniform. Okay. So from a discrete uniform distribution, I want to create 40 numbers. So the first number that you see inside the parentheses there, that is the size of our data set. That's our N. Okay. The second number you see there, that is the smallest value that we want to have in our data, and then the largest value is 20. So numbers from 1 to 20 can appear in our data, and we want there to be 40 of them. Okay? So RDUNIF parenthesis 40, 1, 20, close parenthesis. Okay? So that's 2 lines of code that we're typing in. The third line of code is literally just to repeat the name of our data. We're just typing in the name of it because that's just going to print it out. That's what that does, is it just prints it on display. It'll put it on the display for us. And then the last 2 are creating a histogram and a boxplot. And you'll notice that for both of those, we actually had to refer to our data set by name. Okay? So anytime you're doing something with your data, you need to actually refer to it by name inside the parentheses there. So we're creating it, we're printing it, we're making a histogram, and we're creating a box plot. Okay? So let's go over to that website. This is rdrr.io/snippets. And we're going to just delete everything that we see there in the box. And we're going to just type the ones that we want to have. So the first thing we want is our package that we need to use, extra capital DISTR close parenthesis, and then just hit enter. And then on the next line we have D20 rolls equals and RDUNIF currency, and I'm just going to start with 40 values from 1 to 20. So 40 values from 1 to 20, and then I'm just going to type D20 rolls. I'm just typing it on the next line. That will print it out. And then I'm going to create a histogram, and it's not histogram, it's just HIST D20 rolls. And then underneath that, we're going to create a box plot of D20 rolls. So it's literally just those 5 lines. And I know it doesn't like how we've spelled things, but that's just the spell checker being silly because this is code that we're typing in. Okay. So there's our histogram, there's our box plot, and there's our list of values that you see here. Just ignore the numbers that are in brackets. The brackets are telling you like what the index is. So we've learned about the index. The index is basically counting how far into the data set you are. So starting with the first value is number 6. And then when you go down to number 19, that's the 26th value in the list. So I think if you count all of these going across, you'll find that there are 25 numbers there. So bracket 1 just means you're going from the first value all the way out to the 25th value. And then bracket 26 just means that the first number you see there is the 26th number in the list, all the way out to, and then the last one is the 40th. Okay? So it doesn't look very uniform to me according to the histogram, but if we add an extra 0 onto the 40 here and make it 400 and try running it again, so now we're going to have 400 values of rolling a D20. So like think of this as I've actually gotten a D20 out and I've rolled it 400 times. And instead of actually going through all that effort of rolling, these numbers are all the results of rolling a 20-sided die 400 times. And the histogram is looking much more uniform, and your box plot is looking much more centered at the very center of our numbers that ranged from 1 to 20. So, and that's very much what we expect. We expect the box plot to be very symmetrical. Okay, so this is just giving us a visualization of what a uniform distribution looks like. Okay, and we're going to be doing that with all of the distributions that we're learning about into the future. So you'll see a separate video for each one. Okay, like, subscribe, comment down below, and I hope you find these videos helpful.